Projectile motion, ground to ground projection. What is projectile motion? When any object is thrown and it transverses the space under gravity on earth, we call that motion as projectile motion. The path of the projectile is usually a parabola under constant acceleration due to gravity. So this is the path of the projectile. Here we have drawn the x-axis to be parallel to the ground and the y-axis to be perpendicular to the ground. So when a projectile is thrown or projected, we have a certain set of parameters that we define with respect to this projectile. So the velocity of projection happens to be u and the angle of projection happens to be theta. The height, the maximum height that the projectile reaches from the ground is labeled as h max. The distance that it traverses from the point of projection to the point of landing, so I'm labeling the point of landing as L and the point of projection as O. So the distance traversed by the projectile from the point of projection to the point of landing is called as the range of the projectile. The time it takes to reach the maximum height is labeled as time taken to reach maximum height, T subscript h, and the time it takes to reach the range or transfers the complete motion is called as the time of flight. So another thing that we can observe is that x-axis motion in case of this projectile is going to be completely independent of y-axis motion, and in both the x and y axes we are going to be independently applying one-dimensional equations of motion, since both in the x direction as well as the y direction we have constant acceleration. In fact, in the x direction the acceleration happens to be 0. Hence, the velocity of the x direction, which is initially equal to u cos theta according to vector resolution, continues to be u cos theta throughout the motion. So the x direction velocity remains the same no matter where the projectile is. This is a key feature of horizontal ground to ground projectile motion and may be used in many questions and problems. So all these yellow vectors that I have drawn are parallel to each other and have constant velocity, constant magnitude of the velocity as u cos theta. Now what happens in y direction is just motion under gravity. So the initial velocity in the y direction happens to be u sin theta, again according to vector resolution along the x and y axis. So this is u sin theta, the red vector that I have drawn. Now since it is motion under gravity, the magnitude of this u sin theta decreases with time. The magnitude is decreasing, and at the highest point you get 0 vertical velocity. Then after you traverse the highest point, the magnitude starts increasing in the downward direction. The velocity starts increasing in magnitude in the downward direction, and by the time it reaches its range, the velocity has again become equal to the original velocity u sin theta with which it was projected. So let us analyze a few equations with respect to this projectile motion. So let's understand the equations that have been written over here. So the x-axis velocity ux, which is the initial velocity in the x direction, happens to be u cos theta. The y component of the initial velocity is u sin theta, which we have noted down earlier as well. How does the x velocity change? It does not change because there is no horizontal acceleration or no acceleration in the x direction. So Vx, the final velocity or the velocity after time t in the x direction, happens to be ux, which is u cos theta. Vy happens to be equal to u sin theta minus gt. Why minus gt? Because there is an acceleration to gravity acting in the downward direction. So So downward direction is towards the ground. So the acceleration to gravity is noted as g. So Vy is equal to u sine theta minus gt. What is the x displacement? The x displacement from the point of projection happens to be u cos theta t. And what is the y displacement? It is simply given by the equation of motion, 1D equation of motion, s is equal to ut plus half at square. So here initial velocity in the y direction is u sine theta, and hence y is going to be given as u sine theta t plus half into minus g into t square. Why minus g? Because the acceleration to gravity is pointed in the negative y direction. So simply using the one-dimensional equation of motion, s is equal to ut plus half at square, we get the y component of the displacement at any given time t. So these 6 equations are the basis set of equations which we are going to use to derive a few quantities with respect to projectile motion in ground to ground projection. So the first quantity that we shall be deriving is going to be the time of flight. So how to derive the time of flight? So whenever we are trying to derive a certain something, we have to use physical intuition or logic. So the logic here that is going to be used for time of flight is the fact that when the projectile reaches its range or the endpoint of its motion, then in that case the vertical displacement of the projectile is 0. That is, y becomes 0. So understanding this, what we can write down as y is, according to the equation, it's equal to u sine theta t minus half gt square. So since at time of flight y is going to become 0, we can put it down as 0. Another thing is the fact that at the start of the motion also the y component is 0 of the displacement, and hence you are going to get two answers in time for this equation. So this we can equate to t, taking t common, you get u sine theta minus half gt. So physically this t can be 0, or the bracket u sine theta minus half gt can be 0. Therefore you get t equal to 0 as one possible answer, and t which happens to be the time of flight, t equal to 0 corresponds to the start of the motion, tf which happens to be the time of flight corresponds to u sine theta into 2 upon g. So if you put this bracket as 0, then you get u sine theta is equal to half gt, and then multiplying by 2 and dividing by g, you get time of flight happens to be equal to 2u sine theta by g. Now how to find the time taken to reach the maximum height? So since this motion is symmetric, by intuition we can understand the time taken to reach maximum height is going to be half the time of flight, which is simply u sine theta divided by g. However, let us use a better logic, a logic that will be used furthermore later when finding the maximum height as well. The logic happens to be at time taken to reach maximum height th, the vertical component of the velocity is 0. So the vertical velocity, which is given as Vy, which is equal to u sine theta minus gt, becomes 0. So let's use this fact. By using this, we get u sine theta equal to gt. Remember, we are putting Vy equal to 0. So after putting Vy equal to 0, in order to find time taken to reach maximum height th, you get u sine theta is equal to gt. So this happens to be the time taken to reach the maximum height, t subscript h, and hence th we are going to get as u sine theta upon g. Next, we would like to find the maximum height. So as I said, the logic that we are going to use, or the physical intuition based understanding and reasoning that we are going to use in order to find the maximum height, is the same as the one that we used to find th. So what was that? The reasoning was Vy becomes equal to 0. So again, here are two methods of finding the maximum height. We already know the time of reaching the maximum height th, so we can directly substitute th in the equation of y and get the maximum height, or we can use a better method, a smaller method, uh, in which we'll use the equation of motion Vy square is equal to Uy square. So this is a one step method. The method that I mentioned earlier is a two-step method. So Vy square is equal to Uy square minus 2g h, and since we are talking about maximum height, this is h max, and when the projectile reaches the maximum height, then Vy becomes 0. So what you get is Uy square is equal to 2g h max. Therefore Uy square, what is Uy? Uy is u sin theta, that is the initial velocity in the y direction. U sin theta square upon 2g is equal to h max. So the maximum height will be given as u square sin square theta upon 2g. I'll just note it down over here. H max, this is the commonly widely known formula that the student should know by heart. U square sin square theta upon 2g. This is the maximum height that is reached by a projectile in ground to ground projection. Next up is range. So we would like to find out how far the projectile that or the object that we are throwing goes under gravity. So this path of the projectile, that is also called as a parabola, has this starting point, let's say origin O, and this ending point or the final point, let's say L. I am calling as the landing point. Okay, so how much distance did it travel? What is the straight line distance from O to L? What is the range R? So the range R can be found out by using the logic that range is nothing but x coordinate at time of flight. What is range? Range is nothing but x coordinate at time of flight. Okay, so R is equal to u cos theta into time of flight. So let us recall that the time of flight is 2u sin theta by g. So range is going to be given as u cos theta into 2u sin theta upon g. So here it is important to note and useful to note the fact that 2u sin theta into u cos theta happens to be equal to u square 2 sin theta cos theta. So this also happens to be equal to u square sin 2 theta. This happens to be equal to u square sin 2 theta whole divided by g. Therefore range will be given as u square sin 2 theta by g using the trigonometric identity 2 sin theta cos theta is equal to sin 2 theta. Alright, next up we'll understand what the xy relation is. So we know x and y as a function of time t. We know x as a function of time t as well as y as a function of time t. What we would like to do is eliminate the parameter t and relate x of the projectile with y of the projectile. So how to do that? It's simple. Let's find out the value of t from this first equation. X is equal to u cos theta t. So we get t as x upon u cos theta. X upon u cos theta. Alright. So y is going to be given as y is equal to u sin theta t. T is x over u cos theta minus half g t square. T square is again x over u cos theta square. So simplifying this, we get u or u gets cancelled. So this is x tan theta minus half gx square upon u square cos square theta. So this is the xy equation. On some manipulation, this xy equation can be shown to be equal to y is equal to x tan theta into bracket 1 minus x over r, where r happens to be the range u square sine 2 theta upon g that we have found out a priori. So I encourage students to go ahead and do this mathematical manipulation and check that y is equal to x tan theta 1 minus x over r also happens to be the xy relation that is mentioned over here. Y is equal to x tan theta minus half gx square upon u square cos square theta. Next up is displacement at a time that is less than the time of flight, means the projectile is still in mid-air. So if we want to find out the displacement, so it is simply equal to, let's call the displacement as s. So the s vector is simply equal to the x I cap vector added with the yj cap vector plus yj cap. So this is nothing but the displacement, also called as the position at time t, because initial position was 0, so here the displacement is going to be the position at time t as well. So what is the displacement? So s bar is equal to u cos theta t I cap plus, what's the y component, u sin theta t minus half g t square j cap. So this is the vector displacement. If you need the magnitude of the displacement, it is simply given as root over u cos theta t the whole square plus u sin theta t minus half gt square the whole square. This happens to be equal to root over x square plus y square. Next up, we would like to find the velocity at time t. So the velocity has two components with which we actually already know. The vx velocity remains constant and the y velocity has this value u sin theta minus gt. So the velocity at time t is going to be equal to u cos theta I cap plus u sin theta minus gt j cap. So this is for a time that is less than the time of flight. That means the projectile has not yet landed. So what is the momentum and the change in momentum? So usually some questions are asked relating to projectile motion, wherein let's say this initial point is given, let's say this point is A, and let's say some final point is given, let's say this point is B. So you know the initial momentum, that is the momentum at point A, and the final momentum. So one must note that here the horizontal component of the momentum remains constant, because momentum is mass into velocity. Momentum vector is given as mass into velocity vector. So the horizontal velocity does not change, so the horizontal momentum remains the same. So normally the momentum will be given as p bar is equal to mass into v bar, and we already know the velocity. So the momentum at any time t can be found out. So what about the change in momentum? While finding the change in momentum, again as I stated, the x component remains constant for the velocity vector, and hence only the y component is going to change. And since only the y component is going to change, all we need to do is m into delta vy. You don't need to bother about the x component, because the x components are going to cancel for the momentum. So all you need to do is m into delta vy for the change in momentum. So this is given as mass into, let's say at time t1, this happens to be at time t1, and this happens to be at time t2. So mass into, what is the y component at time t2? It is u sin theta minus g t2. So this is final momentum, which is the momentum at time t2 or at point B in this diagram, minus m into u sin theta minus g t1. Again m into u sin theta gets cancelled, so what remains is m g t1 minus t2. So the direction of momentum change is basically the vertical direction, because this is the vertical direction velocity. So this direction is given as j cap. Now if t2 happens to be greater than t1, then in that case the answer is going to be negative, or the change in momentum is negative. That means momentum has decreased, which is obvious because momentum always keeps on decreasing in the vertical direction, because the force of gravity mg is acting in the downward direction. There was a simpler method to find, if the student is familiar with dynamics, then there is a simpler method to find momentum change. Momentum change upon change in time is nothing but the force. So this is another way to verify Newton's law for projectile motion, Newton's second law. So therefore delta p directly would be given as mg delta t. Delta t happens to be t2 minus t1. So mg t2 minus t1, but mg happens to be in the negative j direction. So that is, if you want to give directions to the momentum change vector, so that happens to be equal to, so mg is in the negative j direction, so that happens to be equal to minus mg d2 minus t1 j cap, which is nothing but the above aforementioned equation. So this is how we find the change of momentum. Next up, we'll understand what happens in case of multiple projectiles that have the same range. So you know that the formula for range is equal to u square sine 2 theta upon g. So in case of complementary angles, what happens is the range comes out to be u square 2 sine theta cos theta upon g. So as we know that if two angles are complementary, meaning if theta 1 plus theta 2 is equal to 90 degree, or if theta 2 is equal to 90 degree minus theta 1, then what happens is sin theta and cos theta, the values are interchanged or exchanged. So basically sin theta becomes cos theta and cos theta becomes sin theta. For example, sin 60 is equal to cos 30 and cos 60 is equal to sin 30, and so on. So let's say this is angle theta 1, and let's say there is another angle theta 2 which is complementary to theta 1. So what I mean is theta 1 plus theta 2 happens to be equal to 90 degree, which is nothing but pi by 2 radians. So in this case, what's going to happen is, for both the angles theta 1 and theta 2, since sin theta and cos theta are being interchanged, a range is going to remain the same. So these are the complementary angles for which the range remains the same. Also, let us also mark the maximum value of range, R max. So what's the maximum value of range? Let's find out. So the maximum value of range is going to be dependent upon this particular expression. So R is given as u square into a trigonometric function whose maximum value itself is 1. The maximum value of sine of anything is equal to 1. So hence the maximum value of range can be equal to u square upon g. So range max happens when sin 2 theta is maximum. So what is the maximum value of range? U square upon g. Okay. And when is sin 2 theta maximum? When 2 theta is equal to 90 degree or theta is equal to 45 degree. So this happens when 2 theta is equal to 90 degree. And the maximum value of sin 2 theta is 1. That's why range maximum is u square upon g. So theta becomes equal to 45 degree. So what does this imply? If you want to throw an object in the absence of air resistance under motion of gravity in a projectile or parabolic path, then you need to throw it at 45 degree in order to maximize its range. In order for it to travel the maximum amount of distance that it can, you need to throw it at 45 degree. So intuitively what happens is, if you decrease the angle, so if you are going to throw a projectile, let's say, if you decrease the angle, then horizontal velocity component is more, however you get less time to traverse. And when you increase the angle, what happens is you get more time to traverse, but the horizontal velocity component is less. That's why this range becomes the same for angles that are complementary angles, wherein theta 1 and theta 2 add up to 90 degree. So when that is the case, the range happens to be having the same value, and the maximum range happens to be when theta is equal to 45 degree. Next up is the discussion of multiple projectiles that have the same time of flight and hence the same maximum height. So what one needs to understand is the fact that maximum height depends only on the vertical motion. Similarly, time of flight also depends only on the vertical motion, because the horizontal motion is unaffected by how quickly or how much with the delay the projectile goes up in the upward direction, reaches the maximum height and reaches the ground again. So let's say if the y component of velocity is going to be the same for multiple projectiles, if u sine theta is going to be the same, then what difference this makes is the projectiles may have different range, however they will have, all of them will have the same maximum height and the same time of flight, because time of flight and maximum height both depend only on the vertical velocity. So this is something to be noted. For multiple projectiles that are thrown with the same vertical component of the velocity, all of them will have the same maximum height and the same time of flight, and naturally also the same time taken to reach the maximum height.